Exada is unique in the environment of testing and evaluating network infrastructure in that it is really an emulation engine as opposed to a simulation engine. Simulation traditionally is a closed environment that does not allow for interaction of external entities such as physical radios, physical battle platforms, to interact with the simulated infrastructure. Exada's differentiation is the ability to bring in those external components such as a real physical radio, a real physical network, and have their data streams flow into and out of and interoperate with the Exada emulated infrastructure. Exada's ability to create an exact digital replica of a wireless network mainly is focused on its structure model, the OSI reference model. As you know, this model provides solid definitions for application layers all the way down through the physical layer of a network. The features of Exada that allow the tool to move data across a network infrastructure are an internet gateway for external network access, a network controller that allows visualization and network interoperation. The tool is SNMP aware, allowing for the interoperation of SNMP-based managers and other devices. It has a packet analyzer in it for capturing data and being able to look into the contents of the payload that are moving through the infrastructure, and a connection manager for managing the overhead aspect of the tool and interoperating with physical networks. Exada's open architecture enables realistic emulations by providing interfaces from the user's perspective, from a network perspective, and from a hardware perspective. The user has the ability to interoperate with the model as the timeline unfolds, causing network failures, device failures, injecting traffic, changing priorities throughout the course of the execution of the model. The hardware in the loop interface allows for the attachment of external networks to the emulated model, allowing for the injection of network traffic from external sources to flow through, to, and across the network infrastructure as it's unfolding in the Exada model. Leveraging multiple processors in the Exada environment from the end user's perspective is a fairly simple task. After laying down the network model, the user presses the play button, at which point the Exada engine makes a determination of the number of available processors and then loads those processors in accordance with the models that are being executed at the runtime. This exploitation is done in an intelligent mode, with Exada determining how to put what protocol on what processor. The entire environment is thread safe. The engine was built with multiple processors in mind from the beginning. It's not just adapted code that is now trying to run across multiple processors.